I think I'm just going to start. So for those of you who don't know me, I'm Joel Bennett, and I'm running low on energy today, so we'll see how this goes. I am a principal DevOps engineer at Lone Depot. I like solving problems with code, and I'm a 15 times PowerShell MVP. And I'm getting pop-up notifications from Teams, which is not good. Hang on, let me exit that. That's gonna be super distracting. Yeah, where was I? MVP, okay, yes. And I have been solving problems with code since, the last century. These are all the ways you can get a hold of me. Those are not all the ways you can get a hold of me. I'm Jekyll, by the way. Online, I am J-Cool. And you can type it that way. And if you go to LinkedIn, Jekyll, or Facebook, Jekyll, or GitHub, that's me. Twitter, on Blue Sky, I had to be jekyll.powershell.social. Oh well. Anyway, so that did not forward to the next slide because this is what we're going to talk about. I added this slide at the last minute with the theory that maybe it would help me to stay on track. It's not going to help. I have reorganized the content of this slide, of this talk. Every single time that I have done a run through, I have moved slides around because I'm having a really hard time feeling like I'm going in the same direction and not just dodging back and forth. So we've got a small group here. Please stop me and ask questions. Go, why are you talking about this? Anything like that. It's super helpful. And I don't mind because this is my long session. I have 45 minutes, guys. This is easy. So what does observability mean to you? Anyone? Situational awareness, monitoring. Okay, so I did not ask all these people this question, but there's a guy that does a podcast, and every year at the at the OpenTelemetry thing, he does an episode called Humans of OpenTelemetry. And the first question he asks them is, what does this mean to you? So I'm going to show you a couple quotes because they're fun. Henrik Rexed from Dynatrace says, having enough information to understand a given situation. Amy Toby from Equinix, being able to look at things coming out of the box and tell what's going on inside the box. These are good. Ryan Mancuso from Honeycomb, actually being able to go out into the unknown and understand how complex systems are performing. He actually said, the full quote is, for me, observability is about being able to ask deeper questions of our systems. Being able to demand, I think, more than just alerting on things that are emergencies and things that we've seen before, but actually being able to go out into the unknown and understand how complex systems are performing. I like that. Tyler Yan from Splunk, he just said, I think observability means that when you wake up at 2 a.m. and have to fix a problem, you can fix it. And ideally, the next day, you're able to look at the code again and find a way to never have that problem again. So I like that also. And last quote from Alex Boughton, also from Honeycomb, when something goes wrong, I can ask a question about my system and get a sense of what is happening without having to know ahead of time what to expect. He also said, it means everything. Observability is life, which I thought was a bit much. So, if he had said PowerShell, maybe. I want to do a little brief history because depending on where you guys are coming from, the backgrounds and whatever, how did we get to starting to call this observability in the first place? So, it's not as small. It's okay. You guys can read that, right? So I like to start in 1999 with this tool called RRD tool. RRD tool was a time series database that threw out the stuff at the end, so overwrite it. So it kept however much space you gave it. amount of logs. It was very, very cool for the time. Nowadays, it's still very cool, frankly, and it's still around. It's open source on GitHub. In 2003, Splunk was founded. Pretty sure that's when it was founded and not when it went public. In 2008, Orbitz released Graphite, and New Relic was founded. A lot of the folks that talk about telemetry and metrics today don't talk about any of these companies because these companies did logs, basically, right? Splunk is a log, well, was, to be fair to them, was a log company. That was all they did. And if you try, it's very, very hard. I was unable to find any articles discussing telemetry or observability that went back any further than 2010. Because the seminal moment for most people of observability is this paper, the Dapper paper that Google published that kind of revolutionized everything and set off this whole new direction, which was sort of the keystone is Zipkin launched, that Twitter created Zipkin, they open sourced it in 2012. Everybody credits Google with setting the stage for Zipkin, and I don't know how true that is. Like if Google hadn't released this paper, Zipkin would never have happened. That seems, I don't know. It's a little hard to believe, especially when it's immediately followed by, Google releases Kubernetes, SoundCloud releases Prometheus, Uber's got Jaeger, and then we start seeing open standards coming out. Open tracing came out. Despite the fact that open tracing came out in 2016, Google released Open Census in 2017, which was a competing attempt to establish a single standard. So in 2019, they merged. And that's what we're going to talk about is OpenTelemetry is the merger of open tracing and open census. It is the case that until Kubernetes came around, I would say Kubernetes accelerated the development of microservices architectures. And it's microservices architectures that made us start talking about observability because we suddenly needed ways to examine stuff that was happening across a whole bunch of different services on a whole bunch of different servers. And maybe we didn't even know which server. And it became a much, much bigger problem than it had been and a very, very different problem than it had been. So anyway, all of this is just to sort of give you a concept of like how long OpenTelemetry has been around. 2019 was the founding of that. They actually, they didn't release 1.0 of their spec until 2021. And the final 1.0 stable version of the protocol wasn't released until 2023. So this is pretty new. Even though if you're interested in this, you've probably been aware of OpenTelemetry for a number of years. The reality is it's just sort of gotten concrete in the last couple of years. Not a brand new thing, but still new to most people. So let's see. Do I want to say anything else before I switch this? No. The actual thought that I had about this thing with all these different tools, the thing that happened up until OpenTelemetry, if you had monitoring, you probably had monitoring in a whole bunch of different silos, right? You had Splunk for logs, and maybe you had Datadog, or you had New Relic for like metrics, or you had, what's the one, my brain just stopped, Graphite, or Jaeger for tracing. And you had all these different things and everything's in a silo and you can't correlate, I don't know about you guys, but I have held a sheet of paper up to my monitor to try to put two graphs next to each other and see if the event happened at the same time. It's a thing. So back to the original question. What is observability? And I'm going to answer it kind of like the official. Observability is the ability to measure and understand the internal state of a complex system from the outside based solely on data that the system emits without having to rely on internal knowledge or assumptions about how the system works, right? So the idea is we need to understand how it works without knowing how it works, right? Just based on the data that's coming out of it. And we say that the more observable a system is, the easier it is to troubleshoot novel problems, right? The unknown unknowns, the unexpected problems you've never seen before, and get to root causes. So I think, yeah, let's do this one more slide. Actually, no, I have 4 slides, and then I'm going to do a demo. So telemetry systems, telemetry signals. When we talk about observability, we're talking about this data that gets output by the system. That data we usually call signals or telemetry signals, some combination of those words, depending on which marketing department wrote the stuff. That data that we need to generate in order to be observable are telemetry signals. In general, I just realized how hideously bad that yellow is to read. It was black text before, but I switched my color scheme in. Anyway, so 3 signals that we mostly talk about: logging, tracing, and metrics. Logs are timestamped text records of discrete events. In the modern era, they're usually structured and frequently contain contextual information about the event or the environment where the event happened. But these are the oldest, most common, and most widely used data, right? We've been doing logs since at least when I started working in the industry. You notice I didn't say a year there? That was, metrics are quantitative measurements of some element of a system at a specific point in time. So the important part is quantitative and time, right? You can measure anything that you want to measure, but the important part is for it to be quantitative and time stamped. Traces are about following the path of an event through a system. So they give us a big picture of what happens when, like, let's say a web request is made to the front end. What does that trigger? How does it go through the system? Because usually when we're talking about these kind of micro framework or microservices systems, we're talking about lots of little systems that all of them handle that same event. And so they start from there. So these are the sort of 3 signals we have. There are a lot of different things that we can do with them. I'm going to highlight 3 different approaches to monitoring, which I think, I'm being very careful to use the word monitoring in these next 3 slides. We're talking about ways of doing monitoring, not observability, but they're very closely related, right? So, Brendan Gregg, I don't know if you've heard of him. Oh man, where are we on time? 1:13. Have you heard of Shouting Guy? No. Okay, is my mouse on my screen or your screen? That's really weird. Okay. Oh, I said I wasn't going to do audio, and now I'm doing audio. Okay. Well, anyway. Okay, so this guy, I'm going to narrate, right? Here's the bottom line. This guy discovered, he's in a data center. He's going to show you this. Have you seen this? Any of you seen this before? Yeah, okay. So he's got a graph here of his hard drive latency, right? And he's going to go over to the rack of hard drives. He's just pointing out how well they're doing, right? Look at this flat line. It's really, really good. And then he's going to go over to the rack and he's going to tell you, don't do this at home. And then he's going to shout. That's all he's doing. He's just yelling. And you can see that spike in the latency. What? Because it turns out that audio interferes with spinning disks because it causes vibration and it slows down the drives. Isn't that crazy? Okay, anyway, he is famous for this video. I'm sure he regrets that, but he does actually mention it on his own website, so maybe not that much. Oh man, can I get back? I'm like, where's my browser? I am on the right window. Back. That's so weird. Okay. Up at the top. Oh, it's because it opened in a new tab. I'm like, why is back not working? Okay. Sorry. I did not rehearse that because I wasn't going to show that video, but we got time. So, okay, that guy is actually an Intel fellow now. He's internationally renowned expert in computing performance. And one of the things that he's done that I think is super cool, because I'm totally obsessed with this, is he pioneered the use of eBPF as an observability technology. If you don't know what that is, ask me later. He talks about the use method, and these are the three things he wants to measure: utilization, the percent of the time that the resource was busy; saturation, which is the amount of work that it still has to do, like the queue length or whatever; and count of errors, right? This is really good for constructing like a checklist that you can go and do a server analysis, and you can identify what resource bottlenecks are in place. So you can go through every resource on your system, like hard drive, network, memory, CPU, and check utilization, saturation, and errors. Usually that will help you find a problem, but this is very server focused, right? It's not great for systems that are many things running on many servers. So Tom Wilkes, the founder, oh, am I not on the, yep, I'm not on the, hitting the button. Nope. Hitting the button. There we go. Tom Wilkie, VP of Grafana now. At the time, he was working at Weaveworks. After he left Weaveworks, he founded Causal. Yes, that says Causal. He promoted, still promotes at Grafana, the RED method, which was rate, the number of requests per second, for example, errors, the number of those requests that are failing, and duration, the amount of time that those requests take. And he says this is better because this shows you what your users are experiencing, right? Because these metrics are the ones that your users care about. If you got lots of errors, your users are frustrated because they're getting blank pages and 503s. If you're taking long, your users are frustrated because your website is slow. I'm not going to take a side in this debate because the Google SRE book says that we should care about 4 signals: latency, errors, traffic, and saturation. I don't know if you noticed, but these are actually the same signals those other 2 guys are talking about, except now we're just going to worry about all of them instead of just 3. So whatever. But these are the, they call them the golden signals. And this is in the SRE book. If you want to know more about it, there's a whole book. I'm not going to go into this. So we're going to go to demos. So this is going to be fun. I have prepared a demo, and we are going to see how it goes. And I got to get my mouse on my monitor instead of yours. In fact, let's do this. Let's send this move tab to the window that's on your, move tab to the window that's on your screen. And did it work? It did. But for some reason, my screen mirroring turned off. And actually, that's not the tab that I wanted to send over there anyway, because what I wanted to send you was, oh, that's so weird. Here, let's do this one. My session has expired. That's what the problem is. Oh. Okay, I'm going to apologize for my corporate infosec. So this is the OpenTelemetry demo. There is actually a repo on GitHub. You can go download and run this stuff yourself. I am running it in my Kubernetes cluster, which for some reason, this is my personal Kubernetes cluster, which for some reason, InfoSec at work has decided poses a risk. And that's why there's a blue banner with my company logo at the top. I told them it was mine, and they said, yeah, so. It's not for work, right? And I said, well, I mean, I use this to teach the guys at work. Does that count? So far, I have not gotten a response. It's harder because I'm not there this week. This only just started happening this week. And it's like Monday morning, I pulled it up on my work laptop. I'm like, no! Because this actually interferes with copy pasting because the stupid Zscaler frame. But anyway, this is the best telescopes to see the world closer. It's just a demo. What happened? Why did it go black? Oh, that's just trippy. Okay, anyway, so Lots of telescopes, cool stuff, right? Behind the scenes, and I just realized I need to send another tab over to you. How do I want to do that? I should probably just send them all. Boom, 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 boom. Now, when I first did this move tab, it said I was moving it to the observability, and now it just says Grafana and 3 other tabs. Okay, so anybody familiar with feature flags? I've got a feature flag control panel here so we can like toggle things. So we're gonna, if my mouse is on that screen, we're gonna turn on a feature. Don't look. I should have kept this page on my side. Okay. Oop. So we turned on this feature. We're going to go look in our Grafana, and I'm going to open a dashboard. Ooh, the dashboard is empty. I'm going to ask you guys to diagnose what's wrong with the website. But it's going to take a minute for that problem to show up because we're looking at an hour of data. So I'm going to come back to this in a second. I'm going to actually, no, we're going to start with this. Check this out. So this is, oh man, refresh. Why not? This corporate thing is, okay, you know what? I'm going to do this. That's a good question. It should go to now, yes. But I'm going to bring this terminal back over to my side so I can type without thinking. Say that again? Oh, yeah, okay, let's see. I don't know if that's why the, now I've gotten my terminal like half on my screen. How is that possible? I'm using the Windows key to move it. It shouldn't do that. Yeah, let's try. Let's just say last 30 minutes. Refresh. See if the dependency chart will load. Hey, there we go. Okay, so this is what the system looks like. It's super complicated. I'll show you another graph later that actually labels these by technology and what they're doing. But you can kind of tell if you can read those labels. I can. I bet you can't. You can kind of tell what's going on. The bottom line is there's a front end, and then there's a whole bunch of services behind it that are serving the ads and the recommendations and the catalog and everything else, right? And we've enabled this feature flag, and we're going to see if anything happens. And we should start to see, so up here at the top, we've got red metrics, right? We've got requests and errors and duration. And we've enabled a feature. We did enable the feature, right? We definitely enabled the feature. We're going to wait and see. We expect to see an error show up, but it usually takes like 5 minutes. There, look at that. Oh my goodness, we've got error rates. So I zoomed in. Now we're seeing errors. So here's the thing. Mouse over these. Where do we look like we're getting errors from? Anybody? Can you see that? Recommendations. What's higher than recommendations is get product. So we can look at these both. So up here in the service, we can look at the recommendation service, or we can look at get product service. Let's look at whichever one we come on first. Here's product catalog. So there's a giant spike in errors here. Get product. We can switch. Did I already send Jagger over here? There's Jagger. All right. So we can go and look in Jagger. If it is I keep thinking my mouse is on that screen and it's not. Like, There we go. Let's look at that same thing, right? Product catalog. And I'm just going to put tag error true. We'll see if there's any traces with errors. Oh my word, a whole bunch of them. And what can we see is, let's see, front end get. This is definitely a problem. Look at that, list products, okay? And what's this one? Get product. Look at that, with a specific product ID. Interesting. So we're gonna go back to the website. I happen to know the product ID is this one. The picture's gone. And we've got no price. We got no, like nothing. This product is gone, right? So we've literally, like without knowing anything about the internals, right? You're able to tell where the product error is because the trace showed right away that we're getting errors from this particular route from the, and we weren't even looking, to be clear, right? We were not looking at the monitoring of this product, of this microservice, right? We were looking at the monitoring of the front end originally when we went into Grafana. Whoop. Control, there we go. When we went into Grafana, I switched the product catalog after we noticed that it had a problem. But we were originally up here looking at the front end because the requests all come to the front end, right? Everybody's on the browser. So all the users are in the browser making these things and we're getting these errors. And we can tell where the errors are just from this one dashboard without even going, I don't have to go deep at all. And this is true for almost all of the kinds of different, like I cheated and showed you this. Oh, where to go? This flag D thing. All of these cause different errors. They're all going to be similar to what we just saw, where there's going to be some feature that's affected, and all of a sudden on the back end, things are going to start failing. The website, I mean, you saw the website's still working, right? But there's this one product that's gone. So this is the point of observability. The point is to say, oh, users started experiencing a problem. There's nothing wrong. The browser, the services are all running, but there is this one service that's not returning results for a certain thing that should be in the database. It was in the database a minute before. It is in the database again now. Refresh. Ta-da! Now we have a telescope. So this is the point, right? I don't need to know how that service, I have no idea how that service works. And I don't need to know because I'm able to diagnose where the problem was and what the problem was, sort of. I mean, not enough to call the developer and say, hey, why are these products disappearing from our website? Okay, so now I'm gonna go back to slides, maybe. Ooh, to the first slide, special. Oop. So the key thing here in telemetry is that each signal works as a cross-cutting concern. So it involves every part of the system, right? Tracing has to go all the way through everything. We can't just add tracing to one place and make it work. Metrics have to go from everywhere because we can't, like that dashboard, the only reason that works is because I have the tracing, because that's what that dashboard that I showed you was just spans, which is traces. I'll talk about that a little bit more. But spans are the way that we report traces because a span is not a single point in time, but it's a start and end point. And all of these different metrics, traces, metrics, logs, we need them from every framework, from every application, and we need to have collectors and forwarders and all this stuff, right? Can you see how if I'm like Datadog, this can be really hard to implement for every single possible language and framework. When I was, I want to say it was like 5 years ago, I got a job interview at Datadog. They called me while I was on vacation in Mexico and said, come, we want to fly you out to New York City and interview you. And what they actually wanted was not me. But they didn't know that at the time. And we found that out together. What they needed was a .NET developer who was a reverse engineer and knew the IL level implementation of the .NET framework, because they were trying to write a thing that could inject tracing into ASP.NET and the .NET framework and give them tracing for every .NET app, right? They had to hire a whole team because they had nobody at Datadog that knew anything about .NET. And they were asking me questions that they didn't know the answers to, because they're trying to find out if I know how to reverse engineer the .NET framework. And I'm like, what is it you're looking for? But the problem is that they had to build a whole team for .NET, but they had to do that for every language, right? So this was huge. And it's what eventually leads somebody to say, you know, it would be really cool if like we could use their collector that they already wrote, right? And so we came into a world here where OpenTelemetry comes along and says, look, we've got these cross-cutting concerns, right? How we're gonna get metrics out of each system. We're gonna turn that into an API, and we're gonna make the guys that write the framework write that. And every team, every language developer is gonna be responsible for doing that on their own. We're just gonna make it an API. And because it's the standard, everybody will implement it. And we're pretty sure about this because when they were having this conversation, 90% of them were in the room, right? And then they said, for the stuff that's self-contained, that applies to just your code, we're gonna make an SDK. And we're gonna make that SDK available in every language, or at least somebody is, and they looked at Microsoft. And we're gonna create this, I say, standards and protocols, specifications, if you will. But we're also going to ship APIs and SDKs, and we're going to ship zero code instrumentation agents that will just go in and attach to an existing .NET thing and poof, light it up. But in order for that to happen, we're going to want collaboration from everybody, and that way we're just going to have one agent for .NET. And everybody's going to get the same data because everybody's going to implement the same protocol. And now Datadog doesn't have to write their own, and Splunk doesn't have to write their own, and New Relic doesn't have to write their own because they're all working together on one. So this is the draw, right, for having these open specs. Ooh. So this is incidentally, what that means, if you think about this, is that competition in this market is now basically the UI, right? Because the data is the same everywhere. And if you go and you talk to Dynatrace, they've got like their own agent still. But if you start asking them like, okay, how do we deploy this agent to Kubernetes? They're like, well, we do have an install for that, but you could just use OpenTelemetry. Because OpenTelemetry has a controller that manages it and makes sure that it's injected into every pod and collects all the logs and monitors the actual Kubernetes stats. And it's all done already, and we don't have to actually add all of that. And it's a little bit better than ours. They actually did not admit that, by the way. But they did say we should install it. And they did hem and haw when we asked if we needed both. To be fair. Okay. So what are the standards? The first one is the OpenTelemetry Protocol, OTLP. This is a gRPC protocol for encoding telemetry data. The fact is that OpenTracing and OpenCensus were both developing one of these. And Google, I don't know if you guys know gRPC is a Google protocol built on top of HTTP 2. But Google had been working on this being a gRPC protocol, and they went with that when they came together. The conflicting goals of the OpenTelemetry protocol are to be highly reliable and make sure failures are visible and have high throughput and have low CPU usage and have minimal pressure on memory. And also to support the ability of forwarders to efficiently modify the data on the fly before forwarding it. So the initial release 1.0 had support for traces and metrics and logs. Currently, today, they are working on profiles. That's what they're calling it, which is profiling in another. Well, they added that in 1.30 as the development spec, which probably means it'll take a year or so to come to like final. But this is the protocol. Now, the actual, what's in this, and I'm gonna let you guys, I'm checking clock. You guys pick how deep we go. But the bottom line is that this is, I told you it's based on gRPC and HTTP 2.0. I'm drawing the line at HTTP 2.0, but we don't need to go into this. The bottom line is, if you don't know what HTTP 2 is, HTTP 2 is HTTP in binary. So it basically changed the on-the-wire representation of HTTP to be binary. So instead of sending text, we send binary. And what that did is it made a whole bunch of new approaches possible to data delivery. Mainly that they can multiplex and interleave simultaneous streams of information on a single connection. So when you make a request to a server that supports HTTP 2, instead of opening a new connection for each, for the HTML, for the JSON, for the JavaScript, 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 and for the images, you would open one connection and you would say, I'd like this, and the server is actually allowed to say, oh, if you want that, then you're gonna want the JavaScript, and you're gonna want this PNG, and start shipping you that before you even ask for it. And then when you ask for it, and this is what actually happens in your browser says, I want the HTML, and it gets the HTML back, and it goes, oh, so I also need this. Oh, thanks, you're really fast, because it already showed up, right? So HTTP 2 makes a big difference in the way that we can create one connection and stream data. And when they built gRPC, they built it on top of that. So gRPC is a remote procedure call. They call it a general remote procedure call framework. But it's built on HTTP 2 and protocol buffers. So protocol buffers is a standard for how you encode the data. And Google open sourced that thing, gRPC, in 2013. They actually rewrote something that they had internally because it was entangled in all sorts of IP. So they wrote it again. They literally wrote it again from scratch in order to release it to the public. And they donated it to the CNCF back in 2017. It is interesting because it was being co-developed with HTTP 2 and it depended on HTTP 2. So they took a little longer than you would expect to finish it because they literally had to wait on the HTTP 2 spec to be final before they could say theirs was final. But from the beginning, it's about this concept of bidirectional streaming, right? So I can send concurrent requests without waiting for the first one to return, which means that I can send smaller requests and send lots of them and get higher throughput without having to create giant requests. And it's all with, because HTTP 2 has this built in, gRPC gets gRPC gets retries and timeouts from HTTP 2. gRPC adds load balancing and a service mesh and authentication onto that. So there's a whole bunch of interceptors and client-side load balancing. Client-side load balancing, guys. Like you can stand up a whole bunch of services and the client can make the decision about which one to talk to. So you don't need an actual load balancer between the client requests and the endpoints. And all of this, they had this built across 11 programming languages. So then when the OpenTelemetry team came along, they're like, well, this is really cool. We're going to build on top of that. And OpenTelemetry is this, the OpenTelemetry protocol is this binary request response protocol. It's binary because it's built on top of gRPC, which is built on top of HTTP 2. It is therefore high throughput. It is therefore supports interleaved requests. It therefore supports concurrent requests and responses and retries and timeouts. And in fact, they added a piece where you can get a partial success. So you can send a bunch of data and the server can say, I took half of that, but the rest of it looks duplicate to me. And you can try again and send it with like, you can change it and try again, or you can just say, well, that's fine, and drop it on the floor. But that's what's in the OTLP. That is literally what the OTLP spec is. Now, on top of the OTLP spec, the OpenTelemetry organization is standardizing a whole bunch of semantic conventions. And this is where you guys need to get involved and not just like go read, but actually get involved because they're developing standards for a common set of attributes which provide meaning to data. And an attribute is just a name and a data type, right? So we say, actually I'll do examples in a sec. But an attribute is a standardized name and data type. A metric is a standardized name, type, and unit of measure that has attributes, okay? So they've developed a whole bunch of these for resources, events, metrics, logs, trace spans, performance profiles, a whole bunch of different things. All of these are basically like, well, think of attributes as the dimensions to your data, right? And metrics are those, well, I mean, it's what we were talking about before. It's those measurements. But they are in the middle. They have standardized some of these and they keep adding more. And they are adding more and more areas. So for example, here's a few. There are metrics for HTTP. There are CI/CD and version control system metrics. There are generative AI metrics. There's GraphQL spans. There's like, anyway, there's a lot. And I can dive into, here, look, let's look at one. Let's look at Azure events, okay? So here's the semantic conventions for Azure Resource Log events. And it is very small. Ooh. No, it's not. So you can see the spec here says, this is recommended, this is required, right? And you've got like body fields, stuff that has to be on there. It's frustrating because I made that big enough and now we can't see the recommended or optional at the same time as the name. But you get the picture. So they're building these for everything. And the idea is that as you start, no, how should I put this? Some of this stuff is already being generated by the systems you're using. So Azure DevOps is already generating some of the CI/CD metrics. You're not consuming it because you're not consuming it, but it's there. And you can start adding it to your own systems. You can add it to your pipelines. You can add it to whatever. And we can get to the point where that metric that we were looking at before for like what's going wrong, we can do that on our pipelines. And you can see when a pipeline is failing because all of a sudden you'll start seeing those signals show up in your Grafana, believe it or not. Okay, I have one last slide, I think. Let's go back. I have code, but I think we're gonna skip looking at code. This is that service that we were looking at before. This is how complicated it is. Each of those colors represents a different programming language or framework. And you can see it's like, at the very, very top, there's a load generator. That's why there's any data at all, because obviously nobody's shopping on my website. So there's a load generator that's generating fake data. And then there's a front end, and it talks to all these different services. And some of these services talk to each other, but mostly it's the front end trickling down, right? This demo that I was using is available, like I said, on GitHub, and it has really good docs. It even has at least one example that I did not show today about how to trigger a flag and with instructions for how to go find it in Jagger and Grafana so that you can do a demo. And I didn't use it, so you now will have two things that you know how to find. Okay, so what else? Actually, let's just do that. Does anybody have any questions that I can answer? Yeah. Is gRPC protobuf? Yes. Yes. Any time series database recommendations? I mean, the built-in, like in this demo, we're just using Prometheus. I am currently researching replacements for Prometheus only because I would like it to be a little lighter. And Prometheus has like its own like alerting and stuff that I don't want. So there's a whole bunch. If you look for Prometheus replacements, there's a ton of them. Almost all of them are open source from commercial companies that want to sell you support, which isn't a bad thing, but just for the record. Grafana has their own called Mimir, M-I-M-I-R. I think that's the right one. And it is this is the way that you got to think about it in that space. It is a time series database with a Prometheus API. So literally it's kind of a drop-in replacement for Prometheus. Oh, so this is, let's do this one. So this is OpenTelemetry / OpenTelemetry demo. That's theirs. It is running right now on otel.poshcode.com. You guys can go play with it. Now that I'm done, hit the flaggers, I don't care. It's not gonna be up for very long because it's on my Kubernetes cluster and it had to scale out my Kubernetes cluster to fit. Because it literally did not fit on the nodes that I had already. But I'm using AKS and MVP credits, so who cares? It's free, right? I mean, but then, like literally this is what it's for. I mean, these are what those credits are for. So go play. Anything else? Somebody over here had a hand. No? Okay. Yeah, I think that's time, right? Right? Yeah. I have the code from that OTel demo, and I was gonna show that if we had time. We don't. If you want to catch me in a hallway and ask to see what it looks like. The instrumentation of these things is crazy simple because for the most part, like in ASP.NET, you're basically gonna add a library and say, use OpenTelemetry, and that's it. Because ASP.NET has all been instrumented inside. So you'll get basic, per page requests and all that, and tracing and everything else just by writing a line of code. So I tried to put together a demo for it, and it's a little bit complicated because the built-in instrumentation from Microsoft doesn't really understand PowerShell pipelines. So I'm gonna say no. What I am working on an attempt to basically make a wrapper that would work for scripts that would inject begin and end spans on your begin and end blocks. You know what I mean? But no. Yeah, I have a long time ago, I wrote a module called information. It's on GitHub. I don't think I've actually shipped it to the gallery because anybody that I showed it to, it required me to convince them that it was cool. And so I didn't ship it. But it's a wrapper for write information. And it turns it into, it adds a couple of fields to write information that write information for some reason doesn't already have, that write debug already did have. And so it adds those to the information output. And then it adds the serialization. So you know how in PowerShell, if you want something to come back to you from the remote server, there needs to be a thing that tells it how to serialize so that you can get it back out. And there wasn't, so it just comes out as strings from write information because it's like as if you had written it to host. So I fixed that and I added date timestamps using system.datetime offset so that if the server is not in the same time zone as you can tell the actual time. But there isn't anything, that's it.